This is 8-1's homework for Algebra 1. We are looking at number 1. We're going to write all the two-letter acronyms that can be made from the 5 vowels, A, E, I, O, and U. And if you don't know what an acronym is, if you flip back, you can kind of find it in example number 1 in page 458. How many two-letter acronyms are there? So you have BA, BB, BC. Good example of the question that we're doing right now. Okay, so we're just talking about combining the letters. Acronyms usually stand for something. NFL, National Football League, that's an acronym. Okay, letters that stand for something. So we just have to come up with all the possible combinations for these. So what I think the easiest thing to do is to just start with the A and then attach it to every single letter. So we're going to have AE, AI, AO, and AU. Then we're going to have E with A. Now, even though these are the same letters, they're backwards now, so that still counts as its own. And actually, I forgot one over here. I was just thinking, you can combine a letter with itself. It doesn't say specifically that you have to have two different ones. So you can have AA, AE, AI, AO, AU. So over here, we could have EE, EI, EO, EU. Okay, and then we could start with I. So of course you could have II. And then you're going to have A, E, O, and U. Then we're going to have OO, A, E, I. We already did OO, so OU. And then U. So we have A, E, I, and O. There we go. So for each one of these, 1, 2, 3, 4, there's 5 different combinations, and there's 5 different letters that we could start with for a total of 25. Okay, 5 times 5. We'll get more into predicting how many combinations there are, but for number 1, we just had to write them all out. Okay, next up, question number 2. So it says the Greek alphabet is about 2,750 years old, blah, blah, blah. Contains 24 letters. That's what's important. So we've got 24 different letters to choose from. Greek letters different than our letters. Okay, we're not going to have to write anything out. We're just trying to come up with how many two-letter acronyms there are using Greek letters. So I like to think about it like this. You're going to choose 2 of them to make up a 2-letter acronym like these. The first one, you have 24 different choices. And the second one, because there's no limit here, we could use the same letter like A, E, E. That means there's not 23 choices on your next one. There's still 24. It's kind of like probability. And if we want to know the total number of combinations, we're going to have to multiply this. Remember, this is the same as 24 squared. Okay, sometimes we're going to look at it in that sense. So 24 times 24 is 576. So for part B, how many 4-letter acronyms are there? So now we need 4 letters, and they all can be the same letter. So you have 24 choices each time. You're going to be multiplying. So really, this is just 24 to the 4th power. And that comes out to 331,776 different combinations. All right, question number 3. We're going to write the number 5 to the 6th in base 10, which is also standard notation. Base 10 is what we're used to, regular numbers, and also scientific notation. So first thing we're going to do is go ahead and raise 5 to the 6th power. So that's your standard notation right there. Also known as base 10. And if we want to put that into scientific notation, we are going to put the decimal right after the 1 so that this number is between 1 and 10, 1.5625. times 10 times the power of 10. The decimal was here at the end. We've moved it 1, 2, 3, 4 spots. So it's going to be to the 4th power. Okay, question number 4. Write an example of a 6-letter acronym made from the 5 letters A, B, C, D, E. So you're just choosing any combination of 6 that you want. So I'm going to just say A, B, C, D, E, and then repeat an A. But yours can be anything, any 6-letter combination here. How many of these are possible? How many? So we got to be careful here. We're not using any letter in the alphabet, just these 1, 2, 3, 4, 5 letters. So one way to think about it is just put the 6 blanks. We're choosing 6 letters to make up this acronym, but you have 5 choices each time. And you're multiplying. So 5 times 5 times 5. So we have 6 of them. So this is the same as 5 to the 6th. And this they gave to you on purpose. We just did 5 to the 6th up here. The answer is 15,625. So we're choosing 6 letters out of 5 choices. That's 5 to the 6th power. Here's our answer. We're skipping 5. Number 6. Draw 3 horizontal lines and 4 vertical lines. And how many points do they intersect? So you can count them up. 1, 2, 3, 4. And so in total, we are going to get 12. And you notice we had 3 and 4. 4 times 3 is 12. So as we move to letter B, if you drew 30 horizontal lines and 40 vertical lines, instead of actually doing that and counting, you can see we can multiply those numbers. So you would do 30 times 40, similar to 3 times 4, and you're going to get 1,200. Which again, this came from 30 times 40. So part C, if you drew H horizontal lines and V vertical lines, those are numbers. Okay, we don't know what they are, and how many points would they intersect? Think about what we just did. We took the vertical and the horizontal and we multiplied. So if we're just going to put a variable in their place, we would multiply them together. So it would be H times V that represents the total number of intersections. Okay, question 7. A quiz consists of 10 true or false questions. How many different sets of answers are possible? Let's start there. So you have 10 questions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's only 2 possible choices for each one, true or false. So you have 2 choices, all the way across. So you would multiply all of those 2's. We're going to write this in exponential form first. So this is 2 times itself 10 times. So 2 to the 10th. We're going to write it in base 10. So we're going to actually do 2 raised to the 10th power, which is 1,024. And then scientific notation, we're going to shift that decimal over, so it's 1.024. And we moved it 3 spots, so that is to the 3rd power. Part B, if you guess on all 10 questions, what's the probability of getting all the answers correct? Okay, if you guessed on all of these, what's the chance you get 100% guessing? Well, there's only one perfect combination, right? If you change any of your answers from perfect combination, it's no longer perfect. So there's only one way to do it. So 1 out of your total number of combinations. There are 1,024 combinations. So given 10 true or false questions, if you guess on every single one, the chance of you getting 100% is 1 out of 1,024. Okay, so part C, we're going to answer parts A and B if there are Q true or false questions. So Q just being a variable. So if we go back and we answer question A again, how would we write this out? If you notice, if they're true or false, there's two choices, and you're raising it to the power of how many questions there are. So this would be 2 to the Q power. So if there was 5 true or false questions, it'd be 2 to the 5th. If there was 3 true or false questions, 2 to the 3rd. There was 10 up here, so it was 2 to the 10th. Now, part B, they want to know what's the chance of you getting 100% if there are Q questions. It's still going to be a 1 out of your total number, and your total number is this, 2 to the Q. So you would express it like that. So jumping to number 8. The test has 5 true or false questions. If you're going to write this out, you'd put 5 blanks. And you'd say, how many choices do I have here? True or false? 2. True or false? 2, 2, 2, and 2. There's also 15 multiple choice questions. So if you want to, you would put out 15 of these. I'm not going to write out all 15. There's 4 choices in each multiple choice question. So 4 in every single one of these. I'm going to put ... There's going to be 15 of these. Okay, letter A. How many different sets of answers are possible? So let's just look at the true or false. You would be doing 2 times 2 times 2 times 2. So it's 2 raised to the 5th. We would also have to multiply all of this by our multiple choice questions. But it's a repeated 4. So the base of this exponent is 4. And how many 4s? 15. So this right here is the answer in exponential form. 2 to the 5th times 4 to the 15th. If we're going to do this in base 10, that's standard form, we got to actually get that number. So we're going to do 2 to the 5th. Make sure when you go to hit times, you move over so it's not up there in the exponent. Times 4 to the 15th. And you'll notice we get this in scientific notation, not base 10. So the number is too large for the calculator. It's not going to go enough digits. So what this is telling you is to the power of 10. So we would move this 10 times. You could actually write this now, skipping ahead to the scientific notation, move it 10 spots. But if you go ahead and you look at the answer key, you're going to see that this is not exactly what we've got. So I'm going to grab a different calculator. Every calculator screen is a different size and can fit a different amount of numbers. So let's try it in here. 2 raised to the 5th times 4 raised to the 15th. This one as well, you can see, goes the same amount. So we can only do so much here with our calculators. So in terms of our base 10, I'm going to skip a line. I'm going to go ahead and write this out already in my scientific. Yep, I had that right. Scientific notation, because I already know that this is with a power of 10 right there. So it's 3 point, and I'm going to write out the whole thing. 4, 3, 5, 9, 7, 3, 8, 3, 7 times 10 to the 10th. That's what the calculator is saying there. I'd have to move this 10 spots. So if I did 1, 2, 3, 4, 5, 6, 7, 8, 9, I'd have to put a 0 in that last spot. And the thing is there's actually a number there. The calculator's just gone as far as it's going to go, and so it rounded that last number. So on a higher powered or bigger calculator, you could actually get more digits than we have, okay, that aren't zeros. But in our case, both calculators, this is as far as it's going to go. So when we go to write this out in standard form, we're going to have to move that decimal all the way over. And we're just going to have to add a 0 for that 10th spot. So again, I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, one more 10 spots. And then we've got our answer there in standard form. Okay, so similar to the last question now, if you guess on every single question, what's the chance that you get every single one correct? So the only way you could get every single one correct is if you had the perfect combination of every true or false, every multiple choice. There's only going to be one way to do that, because if you change any of your answers, come up with a different combination, it's no longer a perfect test. So we're not talking about did you pass the test. We're just talking about 100%. It's a 1 out of this number. So instead of writing out that big number, I'm just going to put the exponential form there. And that's what you're going to see in the answer key as well. So it's always a perfect test is a 1 out of the total number of combinations. This exponential form is equal to both of these. So really you could put any of these 3 down here in the denominator. I'm just going to go ahead and put that one right there. Okay, jumping to number 10. Radio station call letters in the United States must start with either W or K. So what they're talking about is if you've heard a radio station like WQXR or whatever, WXTZ, whatever it is, they're talking about the name of the radio station. Okay, it has to start with either a W or a K. So let's just start with the first question, letter A. How many choices are there for the first letter? So it has to start with either a W or a K. So that means there's 2 choices. B, how many choices are there for the second letter? So they don't really specify. You can pick any letter in the alphabet for the next letter. There are 26 possible answers. It could be the W or a K. We're not taking those out. It could be WW, okay, or WK. And so letter C, how many different 4-letter station names are possible? So we're going to have 4 letters representing our radio station. For the first letter, I only have 2 choices. But then my second letter, I have 26 choices. And then I have another 26 choices and 26 choices. So my very first letter has to be a W or a K. But then the rest of mine can be any letter. So my total number of combinations that I could come up with here is 2 times 26 times 26 times 26, which I could have wrote as 26 to the 3rd power if I wanted to. But that total comes out to 35,152. That's a lot of combinations that you could come up with there. Next up is 14. So now we're going to really focus in on these using variables, which takes it kind of one step further. How many different sets of answers are possible for each of the following tests? So letter A, a group of P, that's the number of true or false questions. So think about, let's say there's 4 true or false questions, and we put a 2 in every single one. We represent that as 2 to the 4th. So to answer this question, we know that since they're true or false, that's the number of choices. It's going to be 2 to the total number of questions. So it's going to be 2, and if the total number of questions is represented by P, then that's the answer. 2 raised to the number of true or false questions. Okay, letter B says a group of K questions, so we don't know how many questions, that can be answered sometimes, always, or never. So there's 3 choices. So depending on how many of these there were, 3 choices, sometimes, always, never. 3 choices, sometimes, always, never. When we go ahead and multiply these together, it's 3 to the total number of questions. So if Q is the total number of questions, it's 3 raised to the Q, total number of questions. And then letter C, a test made up of 2 parts, the 2 things we just did. P, true or false questions, and Q, always, sometimes, but not always, or never questions. Okay, so we're basically combining these 2 together. How many different sets of answers are there if we combine all of these and all of these? So similar to what we did on number 8, you take the true or false, and you're still timesing by your multiple choice. So we're taking 2 to the P times 3 to the Q. We would continue multiplying those together and get the total combination. All right, so we are jumping to 19, some review questions. So solving an equation with some fractions. We could go ahead and solve this normally, add the 3/10 to both sides and divide by the 1/5. And you could do that in your calculator. So if you are just confident in punching fractions in your calculator, perfectly fine. But let's also remember the skill of clearing fractions. Okay, so that's what we would want to do here. We're going to go ahead and multiply everything by a number that both 5 and 10 go into, which would be 10. And what the nice thing is that actually clears these out completely. And we'll deal with this one in a second. But since these clear out, This becomes a 9. This becomes a 3. And then remember, this is like over 1. So you're just dividing 10 divided by 5. And so that's going to be a 2x. And now all we have to do is solve this simple equation. So we're going to go ahead and add 3 to both sides and divide. And we're all set. And that's it. And we would get the same answer if you just ran the whole thing with the fractions. But really good skill to have, especially as you move towards your SAT. This could show up in the non-calculator part. Really fast, really easy, clear out those fractions. All right, 20 and 21, we're putting these into scientific notation. So we just practiced this today. So we have to, one, be able to interpret these numbers and then also move them at the same time. So 7 thousandths, the TH tells you that this is a decimal. So this is point. First place is your tenths place. Second place is your hundredths place. The next one is your thousandths. So it's going to be a 7 in that spot, 7 thousandths. So we need to turn this into scientific notation. So that decimal needs to move past the 7. Your lead number needs to be between 1 and 10. So 7 times. This is a really small number. We moved it to the right. So this is going to be a negative exponent. We moved it 1, 2, 3 spots. So it's to the negative third. 21, 2.8 billion. So when a number is written like this, the 2 is in the billions spot. So it's 2 billion, and the 2.8 means the 8 goes in the next spot. And so it's 2 billion. You're going to fill in the rest of the numbers here. This would be thousands, millions. We need billions. And so if we're going to go ahead and turn this into scientific notation, this is going to need to be 2.8. And we're going to have to move it from here to here. So we could do it by groups of 3. That's 3, 6, that's 9 spots. So in scientific notation, it's 2.8 times 10 to the 9th.